I got my hands on, not in, some nitrile gloves. The mother of one of my students uses these in the kitchen, and I was able to acquire a pair for myself, and I thought it would be fun to do a little test. Now you can see here I've made notes of some of the different concentrations of various acids we're going to do. Now, we're going to start counterintuitively with the strongest one, because I'm going to then work backwards and dilute what is left over to get, so that I'm not wasting lots of acid, because I need literally just on the order of drops for this trial. So let us begin. What we have is we're doing 3 concentrations of hydrochloric acid. We're doing 10.2 mole, which is full strength of what I have. It's before the acid becomes fuming. So 10.2, 5 molar, and then 3 molar. I figured 1 molar is just kind of boring, so we're not going to do 1 molar. We will do 10.2, see how that handles it, and then we'll come down to 5, and then we'll come down to 3. So let's get started. I sort of tried to make these little dips, these little kind of bowl shapes. Literally just need, that's still too much, a few drops. Now, let's see. All right, nothing yet, obviously. It's been like a minute, 2 minutes. That seems to be doing pretty all right. Now I have 10 mils, which is still too much, of a 5 molar solution right here. Get rid of most of that. And I guess, I mean, we're sort of answering the question, if the 10 molar solution doesn't do anything, then why would 3 mils of a 3 molar solution, of which we need nowhere near that much. So do anything to the ink? I mean, at this point, even the 10 molar, it doesn't seem to be doing really anything, does it? And nothing, I mean, but nothing changed. All right, so here's just some baking soda in water. So that's going. We'll let it dry, and we'll see if those fingertips have any color change or anything that even signifies that they have had some kind of exposure. All right, folks, we're increasing our production value. I put a light in my shower temporarily, so it will look a whole lot better, although I'm still using a phone and still only able to operate with one hand. We did, before, the 3 mole, 5 mole, and 10 mole of hydrochloric acid with basically nothing. What we're doing now is sulfuric acid. We're going to be addressing that 9.2 mole pinky right over there. What I have here is 9.2 mole sulfuric acid. And gosh, I just need so little. And let's just put it right there and see what happens. Now remember, the hydrochloric did absolutely nothing. it appears, at least at the moment, that this might be the same. Oops, sorry. I'm going to let that sit for a little while, and I'm going to prepare the 5 molar solution. All right, so it's been 6 minutes or so. There's basically nothing there, so why are we going to bother? I've already measured it out though, so teeny little flask beaker. That's 5 mils of a 5 mol solution. So let's. Don't need anywhere near that much even. And put some of that just there to see if it does anything. And then while we're here, ooh, look at that. So, neither of those are doing anything. We will go ahead and neutralize this at least a little bit with some of the same stuff that we used before. Gonna give that some rinsing. Okay, and then basically we're done with this glove. Now for the good stuff. 18.4 mol. Ooh, H2SO4. Let's see. There's actually only a very little bit left in this bottle, so I should probably dilute it down. Please, something, anything? Just for good measure. Put a little bit of it on the paper maybe, see what that does. Just so that we know it's doing something. Oh, it's changing color. Yeah. Finally. I would venture to bet, it would be cool if we had like an infrared thermometer or something. I would venture to bet that that's quite hot. And then right next to it, those 2 drops on the paper are doing absolute, well, not absolute squat, they're bubbling. So, let's, you can see on the other side, the way it's flexing or compressing, not compressing, contracting, the finger is no longer flat. It's like becoming round because of how it is contracting, and it's turning this really cool looking color. I wonder how much of that is going to wash off. And I suppose part of that maybe is that inside the glove is heating up, but now of course it's dripping. Let's not get it on the other fingers. How about that? Let me just zoom out a little bit, sir. Let's not stick our finger out. So that's doing fun things, finally. Obviously, the paper there is having a good time. Yeah. So that's all for the sulfuric acid. We'll wipe this all up, wash it down, and see if see how this cleans up. And We'll have to let all this dry before I want to get to messing with the nitric acid, but spoiler alert, I just got nitric acid. New toy. Let's go. Alright, so trying out a new tripod setup. I don't know that I'm in love with it. I got one of those tripods that where all the legs can bend and twist and stuff, and in theory that's great, but it's very soft and bendy and not as firm and settable as I would like it to be. So we've got first time we're playing with opening nitric acid. This concoction is 16, as it says here, 68%. That should be 16.2 moles. What we're gonna do is we're gonna dilute this by half for 10 mils of a 8.1 molar solution. That'll do, right? Actually, just a teeny bit more. Now I'm hoping. Ooh, I see fumes. I'm hoping that. Oh, of course. I'm hoping that this nitric acid does something, because the other two just didn't. With the gloves, let's see, which glove are we up to using? Here we are. Clunk. So, we're going to start with 8.1 mole and move down from there, and then eventually get up to the 16.2, the pure thing. So let's get a little bit of this out and see what that looks like. First time we're using nitric acid. I don't know. That's left over from the concentrated sulfuric. It burned and charred, and it got like really brittle. And so there's actually a couple of holes. It did burn a couple of holes in how brittle the plastic got. It looks to my colorblind eye like there might be some color change going on, similar to what we saw in with the sulfuric acid, but we're just gonna have to wait a bit and see. So while that's sitting, I'm gonna go ahead and dilute this again by half, and we'll see if anything happens with the 4 molar solution. So that gets us down 68%. This is pure, will be 68. This is 34, and then so that this will be 17 whatever percent, if you think in percentages, but if you're a real chemist, you think in molarity, which is fair. So be right back. What we can do with this and get on to our 4 mole right here, and then if something does happen with this 8 mole, and I think it is definitely changing color. we will have some idea of kind of what the upper limit of nitric acid safety is. But from what I recall, the whole thing has always been, don't use latex with nitric acid. No, sorry, don't use nitrile gloves with nitric acid. So we can definitely see there's a color change taking place with that, which is promising because it's less than half of the molarity of what we had with the sulfuric. Less than half of that molarity. Now we're going to leave this, the 4 molar, for a while. So we've got a very cool kind of greenish color that's different from the yellowish color that this, the sulfuric acid did, and then it eventually obviously kind of carbonized and turned black. But let's give a shot at taking just a little few drops of the pure stuff. This is 16.24 mole, so 68% nitric acid on on a nitrile glove. Let's see what happens with that. Again, we would expect, you know, naturally this to be twice as fast as that, and then this to be twice as fast as the 8 mole, and it does indeed seem very quickly that it's turning colors. And the question is, will the texture of the nitrile change? Will it stretch? Will it become brittle? Will it, you know, eat a hole in it? What will it do? You can see just at that, it looks like it's kind of, maybe that's just a reflection, but it looks like it's bubbling ever so slightly. So anyway, we'll come back in a bit. So what we're seeing that's interesting is kind of this strength of color in a little bit of the weakness, a little splotchy here with the 4 mole, and then 8 mole. Oh, sorry. Yeah, 8 mole. Much stronger, and then here even brighter again. All of the acid from here has either absorbed, oh no, it trickled down behind the thing, so I have to neutralize this whole thing now. Oh look, there it is. There's some more on the back. So you can see the little pattern it created here on the back, and if you can tell in some of these spots where it's kind of raised, there's sort of a raised edge around this bit right here. So it's definitely agitated the nitrile. So what let's do, I have some baking soda solution. Just some sodium bicarbonate. Let that rinse through a bit. So we'll chuck this in a bucket, rinse it all down, and then we can do a review of what the acid did to the glove. So here is, and this is, it's brittle and crusty. This is the hydrochloric acid. It's like it's dried out and comes off in chunks, as if you would think, you know, like plastic that had been burned. So that's kind of cool. That's what that's about. This is the back side where all of that nitric acid dribbled down we didn't do 1 mole. We did do 4 mole. It's discolored. It's ever so slightly raised here, and I want to see. I mean, the 4 mole doesn't appear to have weakened it at all. 8 looks different. Same thing. It hasn't gotten brittle or anything like the sulfuric acid did. It hasn't torn. It hasn't eaten through it. 16, the pure stuff. Oop. All right. Yeah. So it's. I mean, that's a bit of an absurd stretching, but it did get somewhat more brittle. And we can see it's all kind of contracted up here a little bit. So that's that. That's your nitrile gloves, which, I mean, if you pull hard enough with any of those, this 1 mole, the 1 molar that we didn't use, got some sulfuric acid on it, but you know, if you pulled a finger, well, yeah, that came right off. You know, hard enough, it would eventually snap, but it takes quite a bit. So yeah, sulfuric acid was definitely the winner for damage done to the nitrile glove, but that was concentrated. That's some really serious stuff.